So sometimes we are given ordered pairs and we have to determine whether or not they are solutions. So to do that, we are going to take this equation that we are given, which is 2x minus 3y is less than 15, and we are going to plug in these points to see whether or not it's a solution. So for the first one, what do I need to plug in for x?
2.
What do I need to plug in for y?
5.
Is less than 15. What is 2 times 2?
4.
What is negative 3 times 15 or times 5?
Negative 15.
So we have 4 minus 15 is less than 15. What is 4 minus 15?
11. Negative 11.
Is negative 11 less than 15? So 2 comma 5 is a solution. All right, now we're going to do negative 1, negative 7. So what do I need to plug in for x? What do I need to plug in for 3? What is 2 times negative 1? What is negative 3 times negative 7? Is less than 15. What is negative 2 plus 21? Positive 19. Is 19 less than 15? So that is not a solution. Okay, it's not a solution, not no solution. Because this problem does have a solution, it's just not that one. Okay, now I want you to do the last 2 points on your own. So is 3 negative 4 a solution? No. Is 0, 0? Yes, it is. Okay. So now we're going to look at how to graph a system of, or graph a linear inequality. So graphing linear equalities is the best way to see all of the solutions. Okay. So we're going to talk about the steps to graph. So first, we have to put the inequality into slope-intercept form. What is slope-intercept form? Y equals mx plus b. Okay? When we do that, all of our previous inequality rules stay the same. Okay? So that means that whenever we divide or multiply by a negative number, our inequality sign is going to flip. And it tells us be sure to flip the inequality symbol if you multiply or divide by a negative number. Now, we are going to graph the line. So we are going to use a solid line for greater than or equal to or less than equal to. Whenever we have the equal to part, we are using a solid line. Just like when we graphed inequalities before, we used a closed dot. Okay? A solid line is a closed point. Then we are going to use a dashed line for greater than or less than symbols. So if it cannot equal, we use a dashed line. Just like when it could not equal, we used an open circle. Essentially, what's happening is when we have a solid line, we have a bunch of closed dots. Whereas if we have a dashed line, we have a bunch of open dots. That's what's happening. Now, we are going to shade the region that makes the inequality true. So we are going to shade above the inequality whenever we have greater than or equal to or greater than symbols. So if it is greater, we go above. We're going to shade below for the line for x is less than or equal to, or just less than. So before we actually go and start graphing this, I want everyone to go get a ruler and 2 highlighters. Get contrasting highlighters. Don't get 2 that are basically the same color. Yeah. So don't do pink and orange
Actually,
because they're really similar.
we need 2 less. I do not know where my notes are. I left my notes out.
You better be taking notes on your.
She's gonna send me that. You better.
You better still be paying attention though.
No, I am. She's like writing it.
These are funny.
I like those too. Those are my favorite. As long as it has a straight edge, you are good.
No, I didn't. I forgot. I was too busy on how we have purple Sharpies.
That is a Sharpie. Those are Sharpies. Those are highlighters, yeah. This one might be,
Oh, that reminds me. Oh, how much I love that. I will never want to be in it because I don't have my grades. I love it so much. It's like the best chapter in the series. Other than the first grade. Okay. Okay.
You don't say that.
I didn't need anything.
It stinks. I had 107 this class. And when you put my test in, now I have 132. Well, what is it? It's your roller. Obviously, it's a roller.
I know what the forms are. I got Dookie.
Thank you. You didn't have to put an accent on that.
She got Dookie. What?
You didn't put an accent on there.
I just watched my video.
You said it.
I'm going over that. She's gonna get
So what do you think?
Give her your blue now. I just need
All right, so now we're going to look at the first example here below this, okay? So we are going to graph 2x minus 3y is less than 15. So first, is that equation in slope-intercept form? No. So to put it in slope-intercept form, what do I need to do first? Subtract 2x on both sides. So we get negative 3y is less than negative 2x plus 15. What do I do from there? Divide by negative 3. Now, since we are dividing by a negative, what happens to our inequality?
Flip.
It will flip. So we actually have y is greater than. Negative and a negative make a positive. Can I simplify 2 over 3? No. So we're just going to leave it as 2 over 3 x. Can I do 15 divided by negative 3? What is that? Okay, so we have y is greater than 2/3 x minus 5. So now we graph that just like a normal line. What is our y-intercept? And then what is our slope? When we go over, which way am I going over? To the right. So up 1, 2, to the right 1, 2, 3. Now, our inequality symbol tells us all the things we need to know. Okay, is that going to be solid or dashed?
Dashed.
It will be dashed. Okay, it's also greater than. So does that mean we're going to shade above or below?
Above.
So we are going to draw in a dashed line That's really bad. Then we are going to take a highlighter and we are going to shade in the region above. And that represents the solution to that linear inequality. So from here, highlight the region above the dashed line. Yes. Okay. I want y'all to highlight because when you highlight, you can still see the graph. And we're going to do systems of linear inequalities. And when we start looking at systems, it will be very important that we can see which is our shaded region. If you just use pencil lead really harshly, you can't really see the solution region well when we do systems. Okay, so I want us to go ahead and kind of look at those points. Y'all please stop laughing, okay? So from here, if we look at the points that we checked earlier, we're going to talk about when it falls in the solution and when it doesn't. So we already did the point 2, 5. Is that point in our solution? Is that in the shaded region? Yes. Okay. What about -1, -7? No. Okay. 3, -4? 0, 0. Okay. Now, what if I ask you about -2, -2? Is that a solution? What about this point here?
No.
Why is it not?
Because it's not a or equal to sign.
It's not an or equal to sign, so the line does not equal. Okay, that's why we make it dashed. Dashed means it can't equal. Okay. What if I did this point? Is that a solution? So to be in the solution, it has to be in the shaded region or on a solid line. Okay. Now, let's go ahead and we're going to look at a few more of these. So we're going to start with number 1. Okay, for number 1, is that in slope-intercept form? Yes. What is our y-intercept? What is our slope?
1 over to the right 3.
Up 1, to the right 1, 2, 3. Up 1, to the right 1, 2, 3. It will be a dashed line because it is just greater than. So we're going to draw in a dashed line. Now, will we shade above or below? Above, because y is greater than. So shade in above. You do not have to treat it like a coloring sheet and color in every single inch of it. As long as we get the gist of where that shaded region is, we are good. We're going to do systems today too. I'll tell you when you need to use the second color. All right. For number 2. Okay, for number 2, what is our y-intercept? -1. Shh. Okay, what is our slope? Down 2 to the right 1. Now, will that be a solid or a dashed line? It is solid because we have that or equal to part. Now, it is y is less than or equal to. So what does that mean? Does it need to shade above or below? Below. So everywhere. I just did. You don't have to. Okay. All right, then we are going to skip 3 and 4, and we're going to go down to number 5. Okay, And I want us to look at number 5. So is number 5 in slope-intercept form? No. So what do I need to do to put number 5 in slope-intercept form? So we have negative y is greater than or equal to negative x plus 8. Now what?
Divide -4. Oh, wait. Oh, whoa. I'm
Divide by negative 1. So what happens to our inequality? It flips. So we have y is less than or equal to a negative and a negative make a. Then 8 divided by negative 1 is negative 8. So what is our y-intercept? Then what is our slope? Solid or dashed line? Above or below? Then I want y'all to do number 6. All right, so whenever we look at this one, we have to start by putting it in slope-intercept form. So we subtract 3x on both sides. We get 2y is less than negative 3x. Divide both sides by 2. So we get y is less than negative 3/2 x. Why did the inequality not flip? We divided by a positive, so it does not change it. Okay, and then it should be a dashed line shaded below. Because it is y is less than. All right, then we are going to talk about 7 and 8. So number 7 is the line y is less than or equal to negative 4. If I ask you about the line y equals negative 4, is that a vertical or a horizontal line? Horizontal, okay? Since it is less than or equal to, is that going to be a solid or a dashed line? So we're going to do a solid line through y is equal to negative 4. Now, because y is less than or equal to negative 4, should I shade above or below? Below. So everywhere that line and below is our solution. Now, we're going to look at number 8. Number 8 is the line x is greater than 7. If we just had x equals 7, is that a horizontal or a vertical line? Vertical. So whenever we look at this, it is greater than. So am I going to use a solid or a dashed line? So at x is 7, we're going to do a dashed line. Now, a vertical line doesn't really let us go above it or below it. But we can look at where x is bigger and smaller, right? To the left of that line, is x bigger or smaller than 7? Smaller. To the right of that line, is it bigger or smaller? Bigger. So when x is greater than 7, should I shade to the right or to the left? To the right. All right, then we are going to look at systems of linear inequalities. This is why we need 2 colors of highlighter. All right. So we are going to look at systems of linear inequalities. So a system of linear inequalities is 2 or more linear inequalities that are graphed together. The solution for a system of any linear inequalities. So we're going to put the solution is the Thank you. So the solution is the overlapping region of points that satisfy both inequalities. So we're going to look at number 1. When we look at number 1, okay, I want you to take whatever color highlighter you're going to use first, and I want you to highlight the first equation with it. Okay. Then we're going to look at that equation and decide, is it in slope-intercept form? Yes. Okay, now, to graph that, what is our y-intercept? What is our slope? Down 1, right 1. Okay? It will be a dashed line. Okay? So I want you to create a dashed line. Then will we shade above or below? Above. Okay, then we are going to take the second color we're using and highlight the second equation. Is the second equation in slope-intercept form? Yes. What is our y-intercept in that equation? What's our slope? Up 1 over 1. Solid or dashed line? Do we shade above or below? Below. Okay, so the region where our 2 colors intersect, that is the solution to that system. So here, would our solution be here? 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 here. Yes. Okay. This area here is our solution. Okay. Every single point inside that shaded region will satisfy both inequalities. Okay. So using two separate colors makes it a lot easier to see. And it makes it a lot easier for me to grade. Because when I'm sitting there having to look through y'all's pencil scratches, I struggle, okay? This makes it so much easier. This is how I want you to do every single one of these with two highlight colors, okay? It makes it so much easier. So for number 2, I want you to do number 2 all on your own. I don't want you to treat this like a coloring page. Okay, you don't have to color in every single inch of it. I just need to be able to see where your shaded region is. Oh God, I messed up.
Yeah, it's like, that's -4.
Yeah. Whoops.
I thought I messed up for a second. Like, wait.
Nope, that was all on me.
What is my mom? Good. What the fuck?
Oh, hold on. So one of
The y-intercept, right?
Like
Four.
either.
One to the seven.
Do it too.
7 equals up 1 and
All right.
Okay. I forgot.
Now we're gonna go and look at
This one was down 1.
number.
That worked.
I felt it.
We're gonna flip to the next page. And we're going to do 5 and 6 together, and then y'all are gonna finish it. All right. So for number 5. We're gonna start with that first equation. Is that first equation in number 5 in slope-intercept form? So we have to put it in slope-intercept form first. So we have 4x minus 5y is greater than or equal to -35. How do I put that in slope-intercept form? We're going to subtract 4x. So we get -5y is greater than or equal to -4x minus 35. Divide by -5. It flips it. So y is less than or equal to, what does this simplify to? 4/5 x. Because a negative and a negative make a +7. So we are going to graph that now. What is our y-intercept? What is our slope? Up 4, right 5. Can I go up 4 on this graph? I'm going to go down 1, 2, 3, 4. To the left, 1, 2, 3, 4, 5. And will it be a solid or a dashed line?
Solid.
Do we shade above or below? Are we sure? It will be below. Because we had to flip the inequality. Now, if you don't like having, if you want to just shade in like doing lines through it, that's good. If you want to do it just doing like a squiggle, that's good. You do not have to color the whole thing. All right, now from here, we're going to look at the second equation. Does the second equation need anything done to it before we start? Okay, it's good to go. What is our y-intercept? What's our slope? So we go down one, right one. Now, will that be a solid or a dashed line? It will be dashed. And this will go above because it is greater than. And so this area is our solution.
Just do it. I don't have any.
All right, then we are going to do number 6 also together. Okay, for number 6, is the first equation in slope-intercept form? No. So we have 6x plus 4y is greater than 12. What do I do first? So we get 4y is greater than negative 6x plus 12. Now what do I do? Divide everything by 4. I'm dividing by a positive. Do I flip the inequality?
No.
So we get y is greater than. Can I simplify negative 6 over 4?
Yeah.
To what?
3.
So it would be negative 3 over 2x. Then what is 12 divided by 4? Positive 3. Because it's positive 12. So what is our y-intercept?
3.
What is our slope?
Down 3 to the right.
Down 3 to the right 2. Down 3 to the right 2.
Oh, God.
Is that going to be a solid or a dashed line?
Dash.
Do we shade above or below? Now we're going to look at the second equation. Is it in slope-intercept form? Okay, so we have 3x minus 4y is greater than 8. What do I do to put it in slope-intercept form? So we have negative 4y is greater than negative 3x plus 8. Now what?
You divide by negative 1.
And it does flip this time, so we get y is less than
Positive 3/4.
positive 3/4 x
Minus 2.
minus 2. And our y-intercept is?
Minus 2. Negative 2.
And our slope is?
3 to the right.
Solid or dashed line? Above or below?
Below. Oh my God, Frank.
So our solution is this region. So I want y'all to finish 7, 8, 9, and 10. Yes. Yes.